Hey everybody, I wanted to go over question 2118 in Braun-Lemay-Burstin. And so here we're going to talk about a radioactive decay series. Now this is the fun stuff because now we're combining alpha and beta emissions together to come up with a stable isotope of lead. Okay, in this case it's not always lead, but in this case it's lead. Okay, so we're going to start here with thorium. Okay, so I'm going to write that right here, thorium 90 and then 232. And I get it. You may say, well, Mr. Walsh, how do I know which side to write my alphas and which side to write my beta? Well, this is an alpha particle emission, and typically that's what you're going to see, okay, and beta particle emissions. So I know that I'm going to have some number of alpha particles that are emitted plus some number of beta particles emitted, okay? And all of that is also going to give me lead 208, which has this symbol, okay? Now, if we're going to do this, and let me get a different color out here, okay? The only way to change the mass in alpha and beta emission is by using the alpha particle. So here, keep in mind that this side has to equal everything that's up here. Well, this is the only one that is contributing any mass. So what we're going to do is we're going to look at the difference between lead 208 and thorium 232, and we will find out that that difference is 24. Okay, so if that difference is 24, how many of these do we need? Right, 6. Okay, 6 times 4 is 24. Okay, and so that gives us the right mass. Now let me change colors here. I'll go to green. Okay, now what we need to know is that this side has to equal this side in terms of atomic number. Well, this is 90, and this 6, there's 6 alpha particles. That can't change because the mass we already figured out, so that's 12. And this is 82. Well, that's 94. Well, how are we going to get 90 and 94 equal to each other? Well, we need to reduce this side by 4. So that means that this coefficient has to be 4. So what I like about decay series is when it's like a party trick. People talk about nuclear chemistry and they're like, oh, it's so, crazy. And yeah, there's a lot of it that is super crazy, but some of it is fairly straightforward, much like these sorts of problems where you just kind of have to, make sure that things add up, and it becomes, I would say, good party trick to say that nuclear chem. So I hope that helps you at your next party, and have a great day.